Tornadoes are one of the most powerful and unpredictable weather events on Earth. These violent windstorms can form quickly, destroy entire neighborhoods in minutes, and leave behind paths of devastation. But how exactly do they form? The answer lies in the right combination of weather conditions all coming together in just the right way. A tornado starts with a thunderstorm, but not just any thunderstorm. Most tornadoes form from a type of storm called a supercell. These massive rotating storms can grow to be over 10 miles wide and last for several hours. The key ingredient in supercells is wind shear, which happens when winds at different altitudes blow at different speeds or directions. This causes the air to start rotating horizontally, forming an invisible spinning tube in the atmosphere. At the same time, warm, moist air from the ground rises into the storm, while cooler air sinks down. This process tilts the rotating air from horizontal to vertical, creating a powerful updraft. If this updraft is strong enough, it stretches and tightens the rotating air, increasing its speed. Over time, this spinning air column extends downward from the storm cloud, eventually touching the ground and becoming a tornado. Tornado formation is influenced by temperature and humidity differences. Warm, moist air from the Gulf of Mexico and cool, dry air from Canada often collide in the central United States, creating ideal conditions for tornadoes. This region, known as Tornado Alley, experiences hundreds of tornadoes every year. However, tornadoes can form in many parts of the world, from Europe to Australia and even parts of South America. Not every supercell produces a tornado, but when the right conditions align, the results can be devastating. Some tornadoes last only a few minutes, while others can stay on the ground for over an hour, carving a destructive path miles long. In the next part, we will look at what happens inside a tornado and how scientists measure their power. Once a tornado forms, it becomes a rapidly spinning column of air that can reach incredible speeds and cause widespread destruction. But what exactly happens inside a tornado, and how do scientists measure its strength? At the core of a tornado is an area of extremely low pressure. As the surrounding air rushes in to fill this pressure gap, it spirals upward at high speeds. The rotation within the tornado is so intense that it can lift heavy objects, rip apart buildings, and even pull trees from the ground. Wind speeds inside a tornado can range from less than 70 miles per hour and weaker ones to over 300 miles per hour in the most extreme cases. The faster the rotation, the more destructive the tornado becomes. Scientists use the Enhanced Fujita Scale, or EF scale, to measure the strength of a tornado. This scale ranks tornadoes from EF0 to EF5 based on the damage they cause. An EF0 tornado has winds between 65 and 85 miles per hour and usually results in minor damage, such as broken tree branches and small roof damage. On the other hand, an EF5 tornado with winds over 200 miles per hour can level entire buildings, toss vehicles, and leave nothing but a bare foundation behind. Since wind speeds inside a tornado are difficult to measure directly, meteorologists assess the destruction left behind to determine the tornado's rating. One of the most dangerous aspects of a tornado is the debris it carries. Flying debris, such as wood, metal, and glass, can turn into deadly projectiles, causing injuries and fatalities. Tornadoes can also create powerful suction forces, making objects appear as if they were thrown in multiple directions at once. Some tornadoes are strong enough to lift large trucks and even small buildings off the ground. While tornadoes are often associated with dark, swirling funnels, not all of them are easily visible. Some tornadoes, especially those forming at night or in heavy rain, can be nearly invisible until they are right on top of a location. This is why tornado warnings and early detection systems are so critical. In the next part, we will explore how tornadoes move, why some last longer than others, and what meteorologists are doing to improve forecasting and safety measures. Tornadoes are unpredictable and can change direction, speed, and intensity in a matter of minutes. But what determines how a tornado moves, and why do some last only a few minutes while others persist for over an hour? The movement of a tornado is controlled by the larger storm system that creates it. Most tornadoes form within supercell thunderstorms, which are massive rotating storm systems driven by powerful winds in the atmosphere. These winds, known as steering winds, push the storm and its tornado in a specific direction. In the United States, for example, many tornadoes traveled from southwest to northeast due to prevailing wind patterns. However, some tornadoes can suddenly shift directions or even move in loops if the wind conditions change. The lifespan of a tornado depends on several factors, including the strength of the storm the stability of the rotating air, and the availability of warm, moist air near the surface. Weak tornadoes may last only a few minutes before losing energy and dissipating. However, stronger tornadoes, especially those formed by long-lasting supercells, can stay on the ground for over an hour and travel dozens of miles. One of the longest-lasting tornadoes on record, known as the Tri-State Tornado of 1925, traveled over 200 miles across Missouri, Illinois, and Indiana, remaining on the ground for more than 3 hours. Tornadoes can also vary widely in size. Some are narrow, with a width of less than 100 feet, while others can stretch more than 2 miles across. The widest tornado on record occurred in Oklahoma in 2013, measuring an astonishing 2.6 miles across at its peak. A tornado's size does not always indicate its strength, but larger tornadoes often cover a greater area and can cause more widespread destruction. Understanding tornado movement is essential for improving tornado warnings and forecasting. Meteorologists use radar technology to track the formation and path of tornadoes in real time. Doppler radar, in particular, helps scientists detect rotation within a storm before a tornado even touches the ground. By studying past tornadoes and analyzing weather patterns, researchers continue to develop better prediction methods to give people more time to take shelter. As we wrap up, we will look at how tornadoes eventually come to an end, what factors cause them to weaken, and the safety measures that can help protect lives when a tornado strikes. Tornadoes are among the most powerful forces of nature, but they do not last forever. Every tornado eventually weakens and disappears. But what causes this to happen? A tornado begins to dissipate when the conditions that sustain it start to change. The rotating column of air inside a tornado needs a steady supply of warm, moist air from the ground to keep spinning. If this flow is disrupted, such as when cooler, drier air gets pulled into the system, the tornado starts to lose strength. Additionally, changes in the structure of the parent thunderstorm can weaken the tornado. If the storm begins to collapse or move into an area with less atmospheric instability, the tornado will become less organized and eventually break apart. The process of tornado dissipation often follows a pattern. The funnel cloud may begin to narrow and stretch, resembling a thin rope. This stage, known as the roping out phase, is when the tornado becomes weaker and less stable. However, even a weakening tornado can still produce dangerous winds and cause destruction until it fully disappears. Some tornadoes break apart quickly, while others slowly wind down over several minutes. Once a tornado ends, the damage it leaves behind is often analyzed to determine its strength. Scientists use the Enhanced Fujita scale, or EF scale, to rate tornadoes based on the severity of the destruction they cause. This scale ranges from E.F-0, which indicates minor damage, to E.F-5, which represents catastrophic destruction with winds exceeding 200 miles per hour. By studying damage patterns, researchers can estimate wind speeds and learn more about how tornadoes interact with different environments. Because tornadoes can be unpredictable, knowing how to stay safe is crucial. Tornado warnings are issued when a tornado has been detected, and people in the affected area are urged to seek shelter immediately. The safest place to be during a tornado is an underground storm shelter or a windowless interior room on the lowest floor of a building. Mobile homes and vehicles are particularly dangerous in a tornado, as they can be easily lifted or overturned by strong winds. Tornado research continues to advance, with scientists using radar, satellite data, and even storm-chasing teams to gather more information about how tornadoes form and evolve. Understanding these storms helps improve forecasting, giving people more time to prepare and take shelter. Tornadoes may be short-lived, but their impact can last for years. By studying how they form, move, and dissipate, meteorologists and researchers work toward better prediction methods to save lives and reduce destruction. While we cannot stop tornadoes from occurring, knowledge and preparation are the best defenses against their devastating power.